For the next section, you're supposed to be writing proofs or filling in the proofs, right? So these have left blanks for you. So the way to understand these, you've got pictures about triangles, and then you have statements about the triangles that you know, things they gave you. And then down here, you're supposed to be, and then you have what you're going to prove. So as always, you have what you're given and a useful picture, and then what you're going to prove about that picture. And your job is to move from statements and reasons logically from what you're given to what you prove. So notice the first thing that you always write is the thing that you're given, right? You're given that this side, MN, when you divide that by PQ, is the same as NO divided by QR. So you now know that these corresponding sides are proportional to these corresponding sides. They have a scale factor. So what's the reason you know that? You know that because it was given. And here, then, this angle, they're telling you that what they want you to write here is another thing that you were given. This is the other thing you were given. You were given that angle N is congruent to angle Q. So at this point, they're basically saying you're already at the place where you can say what you want to prove. You have enough information. And that's because we know that we've got two sides, two corresponding pairs of sides that are congruent, that are proportional. And we've got the middle angle that's congruent. So by side, angle, side, we now know that the two triangles are similar. So your job is to kind of help yourself try to figure out what's the missing reasons and statements. I'm going to do number 7. Okay, so this one, they're telling you that AB divided by DE is the same as BC divided by EF is the same as AC divided by DF. That's the given. So that's what we write right here. You start with your given. But if you notice, now the next step is already this, what you wanted to prove by side, side, side. So this one was a very simple proof. So this is just getting you used to the idea that you start with what you're given and then you move to what you want to prove. Now, problems like number 11 have a little more steps in between, right? So again, we still start with what we're given. We start with that these two lines are parallel, so that's given. And we know we're going to end with what we want to prove. So we might as well fill that in. We want to end at triangle ACE is similar to triangle BCD. And they're telling us that they proved it by angle, angle. So that gives us a clue about what we need to look for. So now let's go back to what we're given. It may not be obvious to us how we're going to get from here to here, but you want to start with what you can figure out from knowing that they're parallel lines. So knowing that they're parallel lines, what I can tell right away is that this angle is congruent to that angle. And I know that because they're corresponding angles. Parallel lines, once you know something's parallel, you know a lot about the angle relationships that happen when cut by a transversal. So I know that angle A is congruent to angle B and by corresponding angles, right? Well, I also then know that there's a couple other things I could say in here, right? I could either say that I know that angle D is congruent to angle E. Angle D is congruent to angle E by corresponding angles. Or I could just say that angle C is congruent to itself, right? Because both angle BCD is congruent to angle ACE. So that's the one I'm going to write down. Angle ACE is congruent to angle BCD because an angle is congruent to itself. Angles are congruent to themselves, right? So at this point, I now have two pairs of angles. So I should mark this differently, right? So I have the pair of C angles that are congruent. I have the A and B angles that are congruent. So now I have enough to prove that triangle ACE is similar to triangle BCD by angle. So see how this one moved through through some more steps. And the last one I'm going to do as a proof is 13. So again, we're given some parallel lines, right? So we're given this and we move to this. So notice that this is the first thing that they wrote, and that's given. And this is the last thing they wrote because that's what you want to prove. But there's some steps in between about how to get there. So they're saying that angle QMN right here is congruent to angle OPN right here. And we want to know why. Why is that true? Well, we've got these two parallel lines cut by this transversal. So that automatically means we're looking for alternate, these are called alternate interior, and they're congruent. So by alternate interior, these two angles are congruent to each other. Now we need to find another situation, and it looks like we're probably going to need to find another angle because we don't know anything about the sides. And they're telling us it better be alternate interior again. So then we can mark those two. These are the other two alternate interior parallel lines cut by a different transversal. So we know that angle MQN is congruent. MQN is congruent to PON by alternate interior. So now I have two pairs of corresponding angles. So these two triangles are congruent by the angle-angle theorem, right? I want to point out that instead of proving that those two angles were congruent, I could have said that angle M in Q was congruent to angle O in P by vertical angle. So this step could have been that if this had said vertical angles. And that also would have given me two pairs of congruent angles. So there are multiple ways to prove things with triangles. But because of what they offered here, we knew that what they wanted us to do was go for that. Just a couple corrections to the sheet. You'll notice we should always end with what we want to prove. And there's a couple of places with typos where this worksheet doesn't end with what they prove. They just have some typos. So like 15, we know that we want to prove ABE is similar to BCD, but they have this GHI statement. So just mark that out. Triangle ABE is similar to triangle BCD. So this kind of mistake is one that you should easily catch and fix as just a typo. That happened on 12 as well. This should say this instead. On 10, this is what should be right here, right? And on 9, this is what should be right here. So those were just typos about what you want to prove. So remember, move through these with reasons that you've learned, most of them being things like angle, angle, side, angle, side, or side, side, side. These will prove similarity. Then things like vertical angles, corresponding angles, alternate interior angles, right? Those are reasons that will help you prove that angles are corresponding. So look for these kinds of things to help you move through the proofs to tell that angles are not just not corresponding but congruent. So you finish the rest of the proofs.